You bleed. And what happens if you bleed enough? You would die. So we're going to have to figure out how to stop you from bleeding to death. Let's do that. We're going to make a little list, and then it's going to get really ugly really fast.
A little list?
It will become a very big list soon.
So I'm going to start a note page
Okay, we're just going to call it steps to stop bleeding. There's a big fancy word where you can just say that. So I get knifed in the bar in Scio, and then my tissues are damaged. What's the first thing that my body's going to do to keep me from bleeding out on the floor? Look on the screen. What's it say?
Blood vessel.
Blood vessel spasm. Okay, by spasm means changing size. Do you want my blood vessels to get bigger or smaller if you just stab me? I hope smaller. Why would smaller blood vessels be useful?
Less blood.
Less blood, right? You do that when you're doing first aid, right? Direct pressure, you're trying to keep the blood from squirting all over the place. You're trying to force the blood smaller hole. Okay, that's not going to work forever. So number 2, I need a platelet plug. Remember, your platelets were for clotting. So their job is to clot, but not in a direct sense. What they do is they plug the wound. For analogy, just like a cork. Right? If I can put something in the hole, the blood can't come out. So platelets' job is to plug, literally, the hole, corking it. I'm going to show you a picture of platelets plugging. This is not anatomically correct. So here's my knife wound from a student in the bar. Okay? I'm bleeding like crazy. These white things represent platelets. Right? What are they doing there? They're starting to stick. So the fancy word is adhere. They're sticking to the blood vessel. They're sticking to the wound. What did they do there?
Plug it.
They filled in the hole, right? They plugged it. They corked it. So my platelets are going to be sticking to the hole, trying to stop the blood. What's your mom call that thing stuck to your wound? A scab. So the platelet plug forms a scab. So tell me, when you pulled your scab off because you didn't listen to mom, what happened?
Start bleeding.
You start bleeding because you pulled the cork out of the bottle, right? You remove the cork out of the blood vessel. So my platelets are going to start adhering to my collagen fibers, trying to keep the blood back. But that won't last forever. So then I need to do number 3. Formally, the clotting process. Now is when the list gets really long. But the clotting process has many, many steps to it that you're required to know. So don't yell, I'm just the messenger. Don't yell at me. Right? PCC is my parent that tells me what to do. Right? So you're required to know the clotting factors in order, thou shalt. So when I put this on the screen, you'll see on the right-hand side, there are 2 pathways to making your blood vessels clot. You're going to have to memorize both pathways. So on the board, we're going to split the board in half and do both pathways side by side. All right. We're going to have the intrinsic pathway, and we have the extrinsic pathway. Before we start, what's the difference? What's intrinsic mean? Read this sign on this side. Where does it form?
Inside.
Inside of what?
The vessel.
End of the thing, inside the blood vessel. So intrinsic means within the blood system, within the vessels. So the intrinsic pathway is going to start within the vessels. So that's the pathway that would happen if I cut a blood vessel. That's going to start. Extrinsic means with tissue damage. Outside the blood vessels. So if you knife me in a bar, I'm going to have tissue damage and blood vessel damage. I'll have both systems going on. Right? If someone does an IV from you, I'll probably lean in, they're going to do more this one. They're going to poke your blood vessel, hopefully not damage the rest of you. You have 2 pathways depending on where they begin. Okay, for these pathways, you have to know Roman numerals because they write them all as Roman numerals. I will write them in Arabic too, but you're going to have to learn Roman numerals. So we're going to start with all these letters right here.
Oh, God.
I can hear the laughter and happiness. Okay. To get your bearings on this thing, the numbers repeat. Okay, the reason they repeat is the one without the A means inactive, not functioning. The one with the A, we think the A means active or going. So it doesn't change the order, it just means off and on, off and on, off and on, off and on. So as long as you know the number, it's not important that you know if it's off or on. What matters is that you know the sequence. So you're going to start up there at the top. This is the intrinsic pathway. So these are called the factors, or clotting factors. So which factor is the first one in the upper left? Factor 12 begins the intrinsic pathway. So I'm going to write a 12 there in case you don't know that's a 12. Factor 12 turns on the next one, which is factor what?
12A.
Let's see, 12A, yes, which turns on 11. That sounds good. So 12 turns on 11. 11 eventually turns on 9.
That makes sense.
Yes.
Someone forgot.
Here's the problem. They numbered them as they found them, not the order they work in.
Oh my god.
So the order does't make any sense eventually.
Just switch it.
You can't do that, right? You can't do that. This is science. You can't do that. Right. So if you look here, right? So I'm going to scroll down here a little bit so you can see a little more. So if I take 9 and add it to 8, I make 10. So 9 junctions with 7. I'm sorry. Yes, 8, sorry.
Oh, my goodness.
To make 10. So you add 8 to 9 to make 10. That sort of makes sense. Does to me? All right. So factor 12 turns on 11, 11 turns on 9, 9 with 8 turns on 10.
Why?
Because it is.
Because 8 plus 9 equals 10.
At this point, you don't try to figure it out, you just accept this as a reality, right? All right, there's more. Because now we're going to the other side. The extrinsic factor is much easier because there's fewer things.
Okay.
You're going to start with something that's not even numbered, tissue factor. So we're going to say TF. But you're going to start with tissue factor. So on a test, you can put TF. I'm with you. Okay? Tissue factor is going to turn on something. Tissue factor is added to 7 to make 10. So tissue factor, you're going to go down and add 7 to it. And you're going to make number 10. Again. So TF to 7 to 10, extrinsic. 12, 11, 9, 8, 10 on intrinsic. So they both end up at factor 10, either column. But you're not done yet. Because 10, because it's together, they both make 10, that's another pathway. So over here, we're not going to do the common pathway. Since they both have 10 in common, you're going to start with number 10. The one you got there.
Really quick for note,
Yeah.
is that one done so I can just start commenting?
Yeah, that's done.
Okay.
Yeah. So once you get to 10, we're going to combine them both into this mess. All right. So 10 mixes with 5 to become 2. I wish I made this up. I had to make this up. So you add 10 and 5 to make factor 2. Factor 2, though, has a name. That's called thrombin. So factor 2 you can call thrombin or factor 2. Factor 2 will actually make something that's reasonably logical. It will turn on factor 1. So 2 becomes 1. And factor 1 is called fibrin. So another way to say factor 1 is fibrin. If you look in the box in the bottom, fibrin forms what? Cross-linked fibrin polymer. And what does that mean in English, cross-linked fibrin polymer?
Scab.
Not scab per se. That's a clot. So when you get to fibrin, you have formed a clot. The blood actually thickens up. That's a clot. So you're going to go 12, 11, 9, 8, 10, or TF 7, 10. And once you have 10, you go 5, 2, 1. From there or there? Okay. You never pass math with this, right? 12 to 11 to 9 with 8 makes 10. TF with 7 makes 10. Once I have 10, I'm in common. So 10 with 5 makes 2, 2 makes 1. 1 makes a clot.
What happened to all the other numbers?
They went away
Like,
when they
why?
realized it didn't work.
So why don't we just get, if they get rid of numbers, why don't you make them the normal numbers? And like 1, 2, 3, 4, 5.
So what is number? What are the factors? What are they?
What are you trying to do?
So that, yeah.
Makes sense.
Okay.
We know what it is.
We're also curious. I think
Hold on. Yeah, it's okay.
Those are the ones that came up with
Where's the picture I want to show you? Yeah, here it is.
What?
oh my gosh.
Okay. If you really want to walk through this,
Oh my god. No.
here are the actual numbers in order. Again, these are the order they found them, not the order they actually do something in. Right? So as they found these proteins, they'd give them a number, like vitamin A, vitamin B, and then they realized they worked somewhere else. So everyone has a number and or a name. So 3 is also known as tissue factor, right? Calcium, they called factor 4 because they didn't know what it was. They called it factor magical 4, right? So there are actually all the numbers in between, but not all of them directly are in the pathways we're looking at. Right? So I just did the ones that sort of matter for what you're learning. But there are actually 13 factors that are numbered. Then you have a whole bunch that have other little names, little freaky
So
naming stuff.
So the extrinsic one actually does go in order. 3 gets added to 7, and then you end up with 10.
More or less. You get close. Right?
Hey, that's true. It makes sense.
Yeah, that one.
They're all
Tissue
protein.
factor is also
Yeah,
known
but
as
they're all
3.
protein. They're supposed to be
3, 7,
proteinaceous,
10.
but
As
some of them are not
opposed
like
to 12,
factor 4.
11, 9 plus
So
6.
they're things to each other on the way to making a clot.
Yes.
Yeah.
So each one turns on, they're enzymes. So each one turns on the next enzyme that turns on the next enzyme.
Does the tissue factor under extrinsic have a number associated
3.
with it? 3? Oh.
Yeah. But it's not, I use tissue factor. That's what it is. But you can do 3.
So, positive feedback.
Yes. Let me show you. Okay.
Damage to small blood vessels and capillaries frequently occurs. When these vessels are damaged, there are 3 basic mechanisms that promote hemostasis, or the stoppage of bleeding.
Right, so I just got wounded by a student who's mad about the clotting factors, right? So I've got a wound.
Following damage, there is an immediate reflex that promotes vasoconstriction, thus diminishing blood loss.
Right, so make my vessel smaller, direct pressure on the wound, you know, need
Exposed collagen from the damaged site will promote the platelets to adhere.
Right, so now I'm doing the cork thing. I'm trying to shove platelets in the hole to scab it or cork it. So they're going to adhere to that wound to try to plug the pipe.
When platelets adhere to the damaged vessel, they undergo degranulation and release cytoplasmic granules, which contain serotonin, a vasoconstrictor, and ADP and thromboxane A2.
No, you don't have to know this.
The ADP attracts more platelets to the area, and the thromboxane A2 promotes platelet aggregation, degranulation, and vasoconstriction. Thus, ADP and thromboxane A2 promote more platelet adhesion and therefore more ADP and thromboxane. The positive feedback promotes the formation of a platelet plug.
Remember 231 is one of the few positive feedbacks you get because you want the clot to keep going. You don't want it to go away. So you want more clot, more clot, more clot, more platelets, more platelets. So you're trying to positively feedback that system. You want more of it.
So,
Yeah.
hemostatic dressing, do you know what is on that?
I do not, stuff like that. I imagine it's something to do with these, but I don't know.
The final hemostatic mechanism is coagulation. Damaged tissue releases factor 3,
That's
which
tissue
with
factor.
the aid of calcium ions will activate factor 7, thus initiating the extrinsic mechanism. Factor 12 from active platelets will activate factor 11, thus initiating the intrinsic mechanism.
All right, so tissue factor and 3 are basically synonyms. So that one to that one, that one to that one. Then they'll both
Both
mean
active factor 7 and active factor 11 will promote cascade reactions, eventually activating factor 10.
That's the one they have in common. So each side will end at a 10. Then 10, they basically become one path. Right? So 10 is the common
Active
path.
factor 10, along with factor 3, factor 5, calcium ions, and platelet thromboplastic factor, PF3, will activate prothrombin activator.
Yeah, I got all that right.
Prothrombin activator converts prothrombin to thrombin.
Number 2.
Thrombin converts fibrinogen to fibrin.
1. Right? So
Fibrin initially forms a loose mesh, but then factor 13 causes the formation of covalent crosslinks, which convert fibrin to a dense aggregation of fibers. Platelets and red blood cells become caught in this mesh of fiber, thus the formation of a blood clot.
they turn on these enzymes to do that. Yes. You can see the joy in your faces right now. So, so if you want the actual legal document, that's actually the pathway. Right, so I gave you sort of a simplified version of it, but this and this meet here, and that does this.
So
Right?
is what makes the different bleeding disorders different the part of the cascade that they affect?
That's right. So let's think about the disease where you're missing clotting factors. We call people that miss their clotting factors. Hemophilia is someone who's missing clotting factors. Depending on which factor and which side determines what hemophilia you have, right? Because that would tell you how far down the chain you get before you stop being able to make a clot, right? So hemophilias vary by which factor and the severity. So to show you I'm not making that up much, let me show you this picture here. I can. It's a little table. This shows you the different types of conditions and then basically how they affect the clotting mechanism. So depending on what you're missing, like factor 10 deficiency, factor 5 deficiency, they all affect clotting in different ways depending on where in the clotting cascade they affect it. Factor 12, right? So depending on what type of hemophilia you have is determined by which clotting factor, how badly. All right? But that's the idea of the clotting cascades in hemophilia. All right, so we're going to do a little case study on that. So get out your packet one more time. Find the blood clotting case study. Last one we're doing tonight. So Justin, who's 6 years old, happens to be male. Let's see. Easy bruising. Brother died of hemorrhage. Justin bruising. Bad stuff. Bleeding. Lots of bleeding, bleeding, bleeding. So what's your first instinct when someone bleeds all over the place? Probably hemophilia, right? So the doctor's going to run some tests. So now we're going to go through the test and see what's right and what's wrong. Look at his platelet count. Is that okay or not okay? Okay. That's perfectly okay. I mean, it's in the middle. That's okay. His bleeding time. Okay. That's okay. His PT test. Okay. That's okay. His PTT test. Not so okay. All right. So these are all different ways to figure out where in his clotting something is wrong. So there's different tests the doctor would do. So we're going to go down and try to get to those tests by doing number 1 first. So, what medical condition did he have? Does he bleed easily? He has a version of hemophilia. He's a male. He bleeds easily. Remember biology 112, that's a sex-linked disease. Right? So we'll just say he has hemophilia. Now, the 2 tests that begin with P's test different pathways. The PT test checks the extrinsic system. The PTT tests the intrinsic system. So look back up at his data and tell me which pathway is the one that's wrong. See, so the PTT test is wrong, right? Therefore, it must be the intrinsic pathway is not working. Does everyone see that logic? So doctors can test which side of this you're getting. So he cannot perform the intrinsic pathway in the 20 to 30 seconds. He takes double the time. Right? So he has problems with his intrinsic clotting factors. Make sense? Logic? Okay. So what clotting factors might be abnormal in Justin? Let's list them to review. Which ones are in the intrinsic pathway? 12 and 11 and 8 and 9. 10 basically is common. But so 12, 11, 8, and 9. Those would be the clotting factors in the intrinsic pathway.
What about 10?
10 is common, so it doesn't count as, it's in both, so it doesn't count for intrinsic alone. Make sense? So 12 to 11 to 9 to 8. So, ooh, look, they share a common pathway. What clotting factors are in the final common pathway? That's over here.
10, 5, 2, 1.
10, 5, 2, 1. 10 with 5 makes 2, 2 makes 1. So common pathway here, intrinsic, extrinsic over there. So far so good? You can hear the anger, I can feel it. All right, last question. How can his bleeding time be normal if he's missing his intrinsic pathway? It's taking twice as long in the intrinsic system. How can his bleeding time be okay?
It's like
Still gets to the common pathway.
How does he still get to the common pathway?
Because it ends with N, starts with 10.
Right. Close. Anyone see 2 ways of getting to the common pathway? Doesn't he still have an extrinsic pathway? So this one gets you to 10 without needing those. So as long as I have this pathway, I can still get all the way to number 1 using this pathway. If this one were broken, I can still use this pathway. You see why you have 2? It's kind of nice having a backup. So if one pathway is not functioning, I can still get to 10 somehow.
So
That's why it's common.
If factor 10 was messed up, and
Then you have a really
was
bad time.
Then he wouldn't be able to get to the common
Correct.
pathway.
That would make it a problem. There's other little ways you can get around that, but that's the hard one. So it's like that circle of Willis thing. You have more than one way to get to 10. So if one's bad, the other one can take its place. So there's 2 ways to get to 10, is the nutshell. So you can still clot. It just takes him longer if it's just a blood vessel. But you can still get to clotting eventually. Make sense? So for your quiz next week, you do have to memorize the pathways and numbers in order. I could ask you to reproduce them because I'm an evil man.
When you say in order, does it go 9 and 8 are on the same level over there? Like they could go in either order? Or does
No, you have to make 9 first and add it to 8.
Okay.
So you couldn't say that 11 makes 8. You say 11 makes 9. And 8 comes after 9.
So they go 12, 11, 9, 8.